Do you make big decisions or advise those who do? Do these decisions depend on uncertain estimates? And do they have major consequences, either positive or negative, that affect you, your shareholders, customers, employees, and maybe sometimes public health and safety? I'm Doug Hubbard. I would like to talk to you about the methods behind making big, risky decisions. These are the sorts of problems I was helping clients with in the 1980s when I started applying quantitative decision-making methods to their decisions. I've written several books about it. They all have different titles, but they're really all about making measurably better decisions. I promote a selected set of quantitative methods that are very powerful, but they can be made to be surprisingly simple. Because you often have more data than you think, and you need less data than you think, to apply sound analytical methods to your decisions. While I was doing this work as a young consultant, I would often see questionable methods behind some of the decisions clients seemed to have a lot of confidence in. I wondered whether my clients shouldn't be asking some different questions. In fact, I wondered if their single biggest decision shouldn't be a kind of meta decision. Maybe they need to ask how they should make decisions. I came to believe that is the single biggest decision for your company, even your life. In my ongoing research, I looked into the evidence behind the performance of expert intuition, popular qualitative or pseudo-quantitative methods, traditional cost-benefit analysis, and various probabilistic and quantitative methods. And the answer is some methods were measurably better than others, and some popular methods were much worse. That's why in the 1990s I put together a collection of the methods that had the best evidence of improving estimates and decisions. I called it Applied Information Economics, or AIE. AIE is a practical decision-making approach based entirely on methods that have shown a measurable improvement in estimates and decisions. AIE applies to any decision in business or government regardless of how complex, uncertain, or difficult it is to measure. As a management consultant, along with the rest of the team at Hubbard Decision Research, I had an opportunity to apply AIE to several industries on many types of problems over the last 2 decades. These included prioritizing IT software portfolios, what should you approve and what should you do first, prioritizing R&D portfolios in aerospace and biotech and pharmaceuticals, engineering risk analysis and infrastructure development, and even mining engineering, lots of environmental impact analysis, sustainable agriculture analysis, interventions in public schools, even some military applications where we were forecasting logistics for the battlefield and the effectiveness of training. The analysts and academics had a lot of nice things to say about AIE, but more importantly, so did our clients. Our clients from many organizations liked how we quantified what seemed to be immeasurable, how we demonstrated how their decisions could be improved, and how we even showed an ROI on the method itself. Naturally, many of our clients wanted to learn more about how to replicate some of these processes themselves. So we started offering training. We wanted to make the training a combination of self-paced online training as well as live instruction and coaching. We wanted to provide practical spreadsheet-based tools to make even the most complicated methods accessible. And of course, given our approach to everything, we wanted you to be able to measure your understanding and prove it with certification testing. Now, let's review how these courses will help you in your path to better analytics and decision making. The first course is How to Measure Anything, an executive overview of applied information economics. It gives you the research that investigated how common decision-making and estimation methods perform. We look at how expert intuition and even simple cost-benefit analysis can be helpful, and where it falls short and needs a lot of improvement. We also look at extensive research which looked into popular qualitative or pseudo-quantitative methods. We reveal how these methods add no value and can actually be worse than unaided expert intuition, and how some users could still be convinced that it's helping them even when it's not. So then we look at how some select quantitative methods have the best evidence for improving estimates and decisions. We also explain the key fallacies that are really behind resistance to using these methods. In this course, we deal with one of the biggest obstacles to adopting quantitative methods, the idea that some things just can't be measured. They're intangible, some would say. In this course, we reveal that there are only 3 reasons why anyone ever thought something was immeasurable, and how each reason is simply a misconception. Once these conceptual obstacles are overcome, we can get down to the real business of implementing quantitative decision analysis methods. In the course after that, we talk about one of the biggest challenges for your big decisions. The challenge is that most, if not all, of the assumptions behind that decision are actually uncertain. If you are assessing the costs and benefits of implementing a new technology, you don't really know for certain what the ultimate cost will be, when it can be delivered, exactly how much the benefits will be, especially when all these need to be forecasted out a few years. There is even a risk of a major project failure where lots of time and money is spent with nothing to show for it. How do I know the potential benefits justify not only the cost but the risk? So in this course, we'll review probabilistic methods like Monte Carlo simulation, how we can do the math with uncertain numbers. We look at how risk tolerance can affect our decisions and how to quantify it. We'll also explain the measurement inversion. This is the general tendency by almost all decision makers to spend more time measuring things that are statistically less likely to improve decisions. We will show how we can compute the value of information to reduce uncertainty so you can correct for the measurement inversion and actually measure what matters most. In this course, we will provide Excel templates for computing the value of information, quantifying risk tolerance, and an example of a Monte Carlo simulation. Initially, many of the estimates that would populate decision models would come from subject matter experts. But that requires training in how to adjust for some of the common errors in subjective estimates. We have courses for improving expert estimates by correcting for expert overconfidence, for example. If you track experts over time, you will find that they are more confident than they should be in their estimates. That means of all the times they said they were 90% confident in a forecast they were making, they were not really right 90% of the time. But we've trained over 1,500 people in the last 20 years in methods, which allow them to get very good at subjectively assessing probabilities. This is an important source for those probabilistic estimates that go into models. We also find that experts are highly inconsistent. If you ask a subject matter expert to make a long series of estimates where it will be hard to recall exact answers in each case, you will find that they will often give very different answers for identical scenarios. This too can be corrected for with some powerful statistical methods. We can also train you to train others in your firm in all of these methods for improving estimates, and even how to evaluate and weight the estimates of SMEs based on their performance. In the next course, Building on How to Measure Anything, our courses on statistical methods of measurement show how we think of measurement as uncertainty reduction, and how we can do the math for several common measurement problems even when it seems like we don't have much data. And you don't have to memorize equations or buy new statistical software to do this math. Like with the previous course, we give you ready-made Excel spreadsheets. In this case, they contain the instructions for estimating things with random samples, Bayesian methods, controlled experiments, and more. In another set of courses, we teach the details of building those Monte Carlo simulations that we showed an example of earlier. This builds on the concepts introduced in How to Measure Anything in Decisions Under Uncertainty. There is no required Visual Basic or add-ins, just native Excel you already have, whether it's Mac or PC. We will also give you the formulas for HDR's own powerful and flexible pseudo-random number generator. It will support even the largest and most complex simulations you are likely to need. Finally, we have several elective courses on special topics. We show how you can use the thought process behind applied information economics in cybersecurity risk analysis, enterprise risk management, project management, measuring innovation, and measuring organizational transformation. And we add new ones from time to time, often based on customer requests. So let us know if you think another course about measuring a difficult problem will be of interest to you. You can take most of these courses independently of each other, but if you complete the entire series of training, you can sit for the Aie Certification Exam. Just scroll down on this webpage to see the full list of all of our training, both computer-based training and live workshops. And you can email us at info@hubbardresearch.com if you have any questions like how to get group rates or private live workshops for your firm. So measure what matters. Make better decisions. Your path to better decision making starts here.